So welcome back. In this video, we're going to talk about working with an average value of a function and working with an average rate of change. And this will mostly focus on average value, but it can be difficult to ascertain whether whether a question, right? This two shouldn't be there. It can be difficult to ascertain whether a question asks you to determine the average value of a given function or the average rate of change of a given function. So to solve, you need to identify what function you're looking for the average value of. So as an example, if you're asked to find the average value of f of x, then and you're given f of x, well, here's the formula for the average value, right, on an interval a to b, right? We're going to have the 1 over b minus a, the integral from a to b of f of x dx. But if we're asked to find the average rate of change of y equals f of x, then we're going to use this average rate of change, or this AROC formula, right? What we also know as a difference quotient. The change in the value of the function divided by the interval in which that change occurred. Right? In other words, the slope of the function. But please be careful with the wording and with the phrasing. It's very important. In particular, if you're asked to find the average value of a rate of change. So if you're asked to find what's the average rate of change, but the function you're given is a rate of change function, then you're going to be using the average value of that rate of change function. I know, confusing. So hopefully these examples will help clarify a little bit. Okay, so we have this first example, and I don't have a calculator with me, but this is a calculator-based example, right? And we say that the rate at which water is sprayed on a field of vegetables is given by some function with respect to time, and that function is a rate function. It's kind of like a velocity, right? That rate function is in gallons per minute. Okay, so we're in gallons per minute. And during the time interval from 0 to 4, what is the average rate of water flow in gallons per minute? So notice we're asked to find the average rate of water flow in gallons per minute. The function we're given is measured in gallons per minute. Therefore, we need the average value of that rate function. I know, confusing, but use the units to help you out. So we're going to substitute into our equation 2, right? The average value function. And substituting into that equation, 1 over b minus a, b minus a, all over the integral times the integral from 0 to 4, in this case a and b, of the function. If I use the integration feature on my calculator, right, I get 14.69. Okay. For those of you watching this video in preparation for AP exams, the AP exam currently requires answers correct to 3 decimal places. So the answer should be presented as 14.691. For those of you that might be watching this for other exam services or for another course, be aware of the accuracy that you're expected to use. All right? But the average value of a function will be used if you're asked for the average value of the function that you're given. Now, what else can this look like? Well, I have also my average rate of change. Okay, so a simple example, but important. Let's say that we have a particle that moves along a straight line, so the position of the particle is given by some function, s of t. Write an expression for the average velocity of the particle, right? And the average velocity of the particle is going to be the average rate of change for my position function. So we're only given the position equation, and we need the average velocity, or the average rate of change. So we need to use that third equation to determine the average rate of change of position. So I'm going to have the position at 8 minus the position at 2 all over 8 minus 2. And consequently, if we were asked for the average position, right? If we were asked for the average position, then we would have 1 over 8 minus 2, the integral from 2 to 8 of the position function, right? And unit analysis can help us here. Unit analysis or dimensional analysis can help us. That if I have my position with respect to time, right, then this maybe is given in centimeters and time is maybe given in seconds, but then I'm dividing by a change in time. So then that means times 1 over seconds. And the net result would be 1 over seconds times centimeters times seconds would be a position in centimeters. Whereas this down here, we would be saying like, hey, here is centimeters minus centimeters, right? Or in other words, right, we'll say centimeters at 8, we'll say centimeters at 8 and centimeters at 2, right? And then time at 8 and time at 2, which really is just change in centimeters all over the change in time, right? And we could say, okay, well, that's centimeters per second, which is a rate. So be careful about what you're asked and make sure you have it organized. Okay. Now, additionally, had we been provided the velocity equation, then the average velocity, given the velocity equation, would use that average value of a function equation. So be careful, be aware, and make sure that you get the practice that is needed. Thank you for your time. In the next video, we'll look at some examples.